Hi guys. Thanks for the Rob. Please, when you have questions, just yell at Rob. And what I want to do here is talk a little bit about a project that I've been involved in now for about 5 years. We're just winding up our funding for this project. And this is a U.S. Dimensions of Biodiversity project that was about the assembly and evolution of the biota and its environment and integrated approach. And boy, that's a big challenge. And what I want to do is talk about the challenges because I think they're really relevant to understand how difficult it can be to kind of pull together the data resources, knowledge resources, but the intellectual capital around understanding the Amazonian biota and how it's changed over time. I want to make sure I point out that this project is really meant to be fully interdisciplinary and integrated mostly around earth sciences and life science and biodiversity. And that the project really has an evolutionary stage. It's been meant to kind of be that fulfillment of the past and fulfillment of the future. So that in mind is sort of a brief overview of what I'll talk about. I want to kind of dive into what this project actually is all about. I think it's indicative of the challenges that we face when we're trying to think about how to get a comprehensive view of Amazonian biodiversity and patterns and processes that have generated that biodiversity. So to give you a bit more detail and kind of walk you through some of the core ideas and thoughts behind how to frame a project of this enormous scope. This is the biggest project I've ever been involved with by people and by challenge and by the enormity of thinking about this. And I think Betty, when I walked in, was doing a great job describing just how diverse the Amazon really is in terms of the geologic histories, the landscapes, the vegetation patterns, the biota is an enormously diverse landscape, and it's been enormously diverse and changing through time. So you have to think about not just the current diversity in terms of geology, paleoclimatology, current climatology, and biota, but you have to think about that as a flip book. You're kind of playing with time as well. But to give you a little more detail on how this project spun up, it isn't just a U.S. project. The U.S. component of this work was funded by NSF under the Dimensions of Biodiversity call. This is a joint project with a really talented group of Brazilian scientists who are funded through Capacity, which is the Sao Paulo funding organization. And so this is co-funded, and so the funding for the U.S. side involved a number of U.S. PIs. I'll tell you more about those people in a second. Index. And there are a really amazing Brazilian PIs involved as well. The goal was to really coordinate activities, and actually as much of behind the science and on top of the science, just to build a network of people who can collaborate around these topics, not just for the period of the grant, but for a long period, for past it, which I think is a really important part of why these joint funding activities really do work, although they have the challenges. So the leaders of the project were Lucia Lohman, who is a botanist at the University of Sao Paulo. Any of you know, I know many of you know this. Any of you guys know she's a great kind of leader. She's well respected, well known as a working in tropical botany and evolution ecology questions for a very long time. Our VPI on the US side is Joel Craycraft, who is a bird biologist in natural history. Also someone who spent a lot of time working in the Amazon and surrounding areas, and I'm really interested in evolutionary questions around area science and the Amazonian biota and how it's evolved. But there were lots of people involved. There were 40 or 50 people total. We go to these great joint meetings at USP in Sao Paulo, and there'd be like 50 people, and just sort of smorgasbord of geologists and paleoclimatologists and experts in butterflies, plants, birds. And it was really awesome and exciting. It's just really being able to kind of meet this amazing group of people. On the US side, just so you know who was involved and to give you an idea of the scope of the project, we went to the PIs. I was mostly involved to help kind of bring together data resources and to kind of build mechanisms and pipelines to help integrate those. And integration is a huge part of this grant. I want to show you right about that in a second. But on the US side, we had a botanist from Michigan, Guralnick. We had a PI from the Field Museum named John Bates, who's bird biologists working in Amazon. We had a remote sensing specialist from City University of New York, Tom Donald, who some of you know, they make it better in few years, who's really great on thinking about kind of the landscape features and areas. We had a geologist from the County Museum of Natural History named Campbell, who's working with some paleo drainages. And we had some other remote sensing experts from Toronto, Sharon Guralnick, who were just fantastic about helping to bring together this big picture. Let's talk about the big picture, the pieces of the puzzle. So these are different sort of subparts of this work. And I want you to read all the text because it's just don't bother. Or if you want to skim it, skim it. It's going to give you the briefest overview of just how much we try to bite off from doing this project. So on the questions on the phylogeny and phylogeography of plants, we focused on two different groups. The Lesothodaceae, anybody know what those are? Bondicea, Brazil nuts, classic tree species, kind of iconic, and the Biodiversity, which is a group that Lucy has been working on her almost her whole career. So lianas, they're beautiful plants, highly diverse in the Amazon. And the idea was to kind of get a better view of the evolutionary histories of these groups, which have been known to smaller or greater groups, are not comprehensive. And really at the level of species phylogenies. And that when you have a species level phylogenies, you can do a lot, linking those to the kinds of distribution data that can reach. I'll be talking about that in my presentation. Okay, so that's plants. The focus is on butterflies. This is with Andy Brower, who's a butterfly biologist, but also a number of really, really well-known Brazilian butterfly specialists. And really the idea was to, again, bring together the phylogenetic resources and the spatial biodiversity trait resources to answer questions about butterfly biodiversity and biogeography. So that was a big part of the puzzle. We also focused on, as you might guess, with Joel Ball, avian evolution, the diversity of birds and their distributions and evolutionary histories. And it brings up a really interesting point about working on groups like birds, butterflies, and plants. These are very different groups, very different traits and histories and characteristics. But also, as you dig in, you realize all kinds of neat challenges. One of these with birds in particular is just how we delineate units of diversity. So many of our questions were really about trying to figure out barriers to gene flow and speciation mechanisms and what would drive speciation in the Amazon. A lot of it has to do with river barriers, other hypotheses. What's really interesting is trying to get down to the level where you're looking at the units of diversity when you're talking about biospecies, which are polytypic and kind of large in distribution. Or phylospecies are more of these narrow delimited diversity. So a lot of the work that we did was talking through how to generate coherent views of diversity, how to get into those points of the path, being able to kind of dive into the phylogenies down to where that diversity really is in relationship to the geology, geomorphology, hydrology. Okay, so we had a group focusing on primates, again, looking at river barriers and also the kind of long-term evolutionary history of the basin itself, the geological history. And so there's a lot of still contentious topics regarding the formation of Andes rows, and we have visual characteristics from the Andes driving into the basin over time, and sort of formation of these major river drainage systems. The questions about kind of the organization of biodiversity from west to east and kind of big scale patterns are still really contentious issues in the Amazon. And so we really wanted to have case studies where we can look at the long-term evolution over millions of years, and also more short-term what are barriers driving diversification. The geological history piece of this work was really interesting. It was basically this sentence right here about sort of creating a model of the physical evolution of the Amazon basin over the last 2 million years, bringing together the geological knowledge accumulated by Brazilians and American scientists, and really creating a way that we can use that model to help us understand why the biota are where they are, how the biota have originated. And so those were really key questions we wanted to answer. We also wanted to pull together the paleoclimatology. You can see this is just a small picture. So we also wanted to pull in a lot of our paleoclimatological knowledge. The challenge there is that we have some data available, steelers, other resources, but assembling a coherent view of paleoclimatology as a space, especially given the importance of monsoonal patterns, how they change over time. Another complex topic. What I learned most is that how much I didn't know. I thought I knew a little bit about all these topics, and turns out I know almost nothing about any of them really, which is a good thing to recognize in science. But we did have a lot of really good discussions in the start towards integrating a cohesive, coherent view of kind of paleoclimatological patterns over time and space, which again is really hard given the huge area, the huge time dependence we're talking about. Okay, almost done with pieces. This is a huge project. So we also wanted to bring in remote sensing, and that was a big portion of the efforts. And that remote sensing gives us something really interesting. It gives us both a way to view landscape, and especially paleo drainages from space. So we can kind of get a view on both past and present hydrology, which is really critical. But the remote sensing also gives you a chance to understand more about ecosystems, how ecosystems are arranged, and the relationship between biodiversity and ecosystem structure and function. And that is still, I think, one of the key things that we'd love to be able to kind of link up at the end of the day. We're not there yet on this, but I think this is one of the topics we'll be coming back to in further grants, further discussions. Okay. So when we put this all together into one picture of what we wanted to do, the reason we have these pieces is that we really want to feed into this sort of Amazonian history question by bringing together systematics, paleogeography, landscape ecology, biogeochemical patterns, paleoclimatology, PopGen, and historical biogeography and phylogeography, combine that and synthesize that into a way we can get a kind of coherent view of history. So that's really a big synthesis that we're after. And it's not trivial to do this synthesis. This figure isn't meant to scare you off or to be too complex. But basically, the integration pieces of the work we did over here, the questions around integrations around biotic histories or earth histories, around evolution of diversity and environment, around scales of around change, are all fed by these big pieces of a puzzle that need to be brought together and kind of combined into frameworks where we need to learn how the Amazon works. And again, no shortage of challenges. And I will say that after 5 years on this project, 6 years almost, where we have learned how far we have to go to get to this big integration. But I do think these kinds of figures that kind of lay out all the pieces that you need to begin to get to that integration are exciting to see put together in a framework, because it gives us a way to begin to think about how to get to the end goals of what we want to be able to do, which is again to use our past to inform the present. I think it's really important we understand that past, evolutionary histories of these groups, to be able to have any ability to make predictions and forecasts in the future under global change. All right. So what I want to do next, I'm going to hopefully speed up a little bit here. I already talked pretty fast. Is the data challenge. So those are the pieces of the puzzle. How do we get anything towards being able to put together the pieces of those puzzles, even the pieces of the puzzle, if you will, to sort of move forward. And so the data challenge we had was enormous. We had mostly incomplete phylogenies that were not well resolved. There are all these questions about taxonomy and limiting species. We don't have distribution maps for most of the taxa in the Amazon. We have some distribution maps for some taxonomy of birds. But for most groups or primates, we lack the knowledge about where species are distributed. We lack knowledge about their niches. We lack sort of these immediately usable morphological data sets. We lack these sort of fully articulated low-spread models of base information, history, timing issues. We don't always have all the knowledge we want about paleogenetics and geology. So what I wanted to do, and as someone who's focused on data assembly, I think is why I wanted to talk about this, is to cover data assembly, is I wanted to produce data and information usable by others, deliver it using informatics tool, and make sure that data was cleaned and of high quality, and to actually work locally in great networks with data producers. And Pam mentioned species linking is a great thing to mention. So because we work so much with the green species, or canals and canals to basically help mobilize information that would otherwise not be. We actually supported a lot of the efforts to make localization of data happen. And so, yay, we got all that stuff done, believe it or not. And what we did was we actually made a little portal, so sort of a portal that is specifically for this project, where you can get clean, usable data. And Ken mentioned, I think, to be fair, I would argue that there's a lot of really high quality data on resources that are out there now.
You just don't know which points they are.
I know, that's the problem. Right? But it turns out we spent a lot of time learning that cleaning is sort of a process, not an end, which I'll talk a little more about. So anyway, this portal is out there. You can get the clean data for a lot of groups we have available. And the cleaning process means we hope that those data points can be better used to be able to help get distribution problems. So when we think about how we can learn about distributions for organisms in the Amazon, one simple way to start with that is to plot points on maps. And Cam showed an example for some of the core tree species. But these point records for natural history collections or observations are a starting point. One nice thing about natural history data is that typically those data are well curated and maintained. We can have some trust in the taxonomic identifications, although not always. And when you think about those point records, they're great, but they're also point presences. They don't tell us their absence, and they have their biases, right? So what we were thinking about are the multiple ways we can develop products, how we can create core scale range maps versus just distribution models, SDAs. And these are critical news sources for spatial diversity analysis that really underpin everything in our projects. So this is an enormous effort, and I'm just going to give you one example for two species that happen to be sister species in the big nodes. But using these point records wisely is super hard. Many of these records were georeferenced, so we spent years georeferencing records, simply to get latitude and longitude on those points. They might have a locality description of where they're collected, but going from a locality to a latitude and longitude can be a challenge. And we also thought hard about triaging these efforts, that we were only georeferencing records that were in unique counties that weren't already available, so we could get a better view of the distribution broadly instead of doing everything, wasting more effort. It's not wasted, but at least being strategic about our choices. And then we had to also do this double check and think about taxonomic applications. What's really clear here is you need experts. You can't do this. A data scientist can't go in and clean data and make good estimates. They need the botanists, the bird biologists, the lepidopterists to help make sure the data are high quality. And we had a lot of great examples where, one of our experts, whether it was Lucia or Chris or other people from our network, who go, oh, I don't trust that person. Their identifications won't look so great. But, oh, that person's really good. So it was interesting to learn how to kind of get the right kinds of data together. So here are those two example species. This is Adenocauma alimendiflorum and Adenocauma bracteosum. These are two different species here, just to show some of a bit of the biology of the organisms. The bracteosum is a picture over here, and this is alimendiflorum over here from the herbarium sheet that's been digitized. And here are the records, the data point records for these two taxa. So as you can see, bracteosum is much more widespread across the basin. Alimendiflorum is a little more narrow in the southeast. So what do we do? How do we get better distribution plots from these point records? These have been cleaned, so we're good about these. These are, just a reminder, these are sister chapter. So we can deliver broad distributions, kind of using expert knowledge to different range products. These are kind of very coarse scale range maps where choices have been made to not include records that were found on the other side of the mountain ranges in the western part of Colombia and Ecuador. So we made a choice to kind of say that this is not continuous habitat. And you can do that, with expert knowledge about these groups and maybe some of the barriers. Here we basically drew kind of more of a straight implementation of this taxon. So that's one way you can think about kind of producing these geographic products. this relies on knowledge of habitat. So we spend a lot of time looking at elevational gradients for these taxa, learning what elevations are found at, trying to figure out where we might have to draw unsuitable habitats versus suitable habitats. So all of these look very simple and actually quite complex in general. And they require a lot of expert knowledge. And whether they're accurate or not is always an open question. We did this for hundreds and hundreds of species to be able to kind of get a general knowledge about where species are distributed, to look at patterns of richness and diversity, as Pam showed in her presentation. We can also create niche models. This is an example of the niche model for Brachyosum. So the niche model is a way of using the climatic and graphic other environmental features of the point presence records and having a background set of climate variables or climate values or soil values or other kinds of characteristics. So these were based on soil and climate. You can generate a niche estimate for the taxon and look at the distribution. And here, the areas that are shown in blue are considered to be highly suitable habitats. The areas shown in yellow or orange or red are more unsuitable habitats. You can see a couple of these points actually fall into unsuitable areas, but the models allow for some amount of missionaries. So this is for that. And the Calia Brachyosum here is the model for Almeniflorium. This is a more narrow range taxon. And here you can see what I've seen on the niche models is that they do delimit unsuitable areas shown in red that are it is a narrower distribution than you might have predicted in your range maps. So the areas in here are actually considered to be unsuitable habitats based on the characteristics of the point presence records in the background that you're modeling. If you're interested in niche modeling, happy to share more about that. But the point is, these are different ways that you can create these species distribution products that are usable downstream for analysis. Just really briefly, to give you one example of that, we looked at a bunch of sister pairs, not just that one sister pair I just showed you. We also looked at the divergence timing. So when these sister pairs diverge, so that's shown here, measured in metric distance. We also measured that in using kind of time calibrations, where we can look at that in a more sort of consumable measure of millions of years or hundreds of thousands of years. This kind of gives you a view of how the depth of divergence between sister pairs. And we're now looking at a measure of range disparity, which is simply how much are the ranges of the sister pairs different size. And we can sort of fit some models about range disparity in relationship to these divergence times. And this gives us some really core information about how we can speciation mechanisms, how species diversify in the Amazon. We have a whole set of measures about range and niche disparities, allows us to kind of make predictions about whether allopatric speciation or parapatric speciation or partial sympatric speciation are drivers here, or whether we're missing the picture entirely using kinds of characteristics that we're interested in. But and I want to mention one last thing before I finish up here. We can also compare these data to the models that have been generated from the other collaborators. So one of our collaborators actually produced these vegetation height models during the last special maximum using kind of really ecophysiologically calibrated models with fire intensity. And so there's always been this question about a dry corridor through the Amazon at the last special maximum. And this model doesn't pick up a dry corridor, but it kind of picks up a dry donut. So questions about whether there are corridors through the Amazon of lower height vegetation, drier area vegetation, similar vegetation. It's always been kind of a key question. And we're getting closer and closer to having better models to ask those questions. We can relate these kinds of models to our species distribution models and begin to understand some of the drivers why species pairs cross barriers that are kind of cryptic. So you might actually see a sister taxon here. This could have been an area of relative barrier past. So my main thoughts on this sort of data-driven science of the Amazon is that what we've done so far is really a first step. There were lots of bumps, lots of learning, lots of challenges in assembling these data sets. And I'll just say that getting these data, producing data at scale for the kinds of questions we went to was enormous effort and much harder than we first think. I don't know if that's similar for other sort of big scale dimensions projects, but certainly for us, I learned a lot, and we're still working on getting out this material. So with that, I really appreciate your attention. I hope I have all of the time for questions.
You're welcome. Thank you.